Hello friends, welcome to video lecture on dynamics of machinery. Today we'll learn about numericals on dynamically equivalent system. So let us start. First one, the connecting rod of a gasoline engine 300 mm long between its centers. It has a mass of 15 kg and mass moment of inertia of 7000 kg mm square. Its center of gravity is at 200 mm from its small end center. Determine the dynamical equivalent two mass system of the connecting rod if one of the masses is located at the small end center. Read the problem carefully. See what's about the given data. So here the distance between the here if you read the problem carefully, the connecting rod of a gasoline engine 300 mm long between its centers means, first of all, what are the information given? According to that, try to draw the diagram as well as try to write the given information, okay, simultaneously. So in this case, small end, okay, is here, big end is here, okay. So center to center distance between both the end, okay. So this distance is given 300 mm, okay. So first of all, write down the long distance between its center, that is L equals to 300 mm, okay. Just convert this into meter, or right now just keep this one as it is in mm, okay. So next one, next information given, it has a mass of 15 kilogram and mass moment of inertia 7000 kilogram mm square, okay. So here write clearly the mass is given 15 kilogram. Next to this mass moment of inertia with a 7000 kilogram mm square. The next one, its center of gravity is at 200 mm from its small end center, okay. This information is given, center of gravity, okay. So if you look to us, the center of gravity is nothing but it is the distance between the center of this one small end, okay, where the mass is located up to a center of gravity point. This distance is nothing but the L1 distance. So write this distance here, okay. Now our aim is to find out the dynamical equivalent of two mass system. That is, you have to find out the value of M1 and M2. Now see the information given. So what's about the information given? Determine the dynamical equivalent two mass system of the connecting rod if one of the mass is located at the small end center, okay. So one of the mass, if one of the mass is located at the small end center, our next aim is to find out the value for M1 and M2. So for that, let us consider kg is nothing but radius of gyration of the connecting rod about an axis passing through its center of gravity g, okay. So already we know this relation, I mass moment of inertia is nothing but m into kg square, okay. So this kg is nothing but the radius of gyration, okay. So already I have seen kg is nothing but the radius of gyration of the connecting rod about an axis passing through its center of gravity g. So we know the value for mass moment of inertia, substitute here. We know the mass, okay, just substitute here. So first of all, get the value for this one, kg. So we know I is 7000, we know the mass is 15 kilogram with us, just substitute here and get the value for kg as 21.6 mm. So next one, information about one of the mass, location of the one of the mass is given, okay. So it is given that one of the masses is located at the small end center. Let the other mass is placed at a distance L2 from the center of gravity G as shown in figure. Let us consider, okay, here is nothing but the center of gravity point, okay. So with respect to this one, one of the mass is located at a distance L1, okay. So you have to find out the ultimately the second distance L2. Okay, you have to find out the location for this M2 with respect to the center of gravity point. Okay, so we know. So we know that for the dynamical equivalent system, so we have with us this one, this relation L1 L2 equals to kg square. Okay, so what's about this L2? L2 from this relation you can get L2 equals to kg square divided by L1. So L1, okay, goes in denominator. Okay, so already the calculations for this kg square with us, just substitute here 466.7, okay, divided by L1. Okay, L1 with us 200. So after calculations we found the value for L2 equals to 2.33 mm. So information regarding the first mass with us, this one M1, mass is placed at the small end center. So you have to find out the information regarding this one, location of the mass, 2 as well as its magnitude. So already we can get the location for this one. So distance L2 already calculated by us. Okay, so next aim is to find out the its magnitude. So we know for dynamical equivalent system, this relations with us m1 equals to L2m divided by L1 plus L2. Okay, for the calculations of m1, and for the calculations of m2, L1m divided by L1 plus L2. So we know the value for L2, substitute here. We know the value for mass small m, we know the value for L1, L2. Okay, so L2 with us 2.33 multiplied by 15 kilogram mass with us. Okay, just substitute here. We know the L1 as 200 plus 2.33 L2 with us. So you can get the value for this M1 as 0.17 kilogram. Similarly, get the value for M2. M2 can be calculated with the help of this relation L1M divided by L1 plus L2. So L1 with us 200 multiplied by 15 kilogram, okay, mass with us. So divided by L1 plus L2 means 200 plus 2.33. Okay, so after calculations we found the value for this M2 as 14.83 kilogram. So here is the answer with us. M1 equals to 0.17 kilogram and M2 with us 14.83 kilogram. So while remembering the formula in case of this M1 and M2, when we write here M1 means when we give the suffix for this one as 1, okay, just let us assume that L2 will come here. In case of M2, okay, when we write the suffix for this one M as 2, okay, so across here L1 will come. Okay, in this way just try to remember this formula. Okay, so without wasting our time we'll move towards our next problem. So next, a connecting rod is suspended from a point 25 mm above the center of small end and 650 mm above its center of gravity. Its mass being 37.5 kilogram. When permitted to oscillate, the time period is found to be 1.87 seconds. Find the dynamical equivalent system constituted of two masses, one of which is located at the small end center. So what's about the information given? Here the H value is given. So to get the clear idea about this, just focus on the diagram. Okay, first of all you have to write the given data as well as simultaneously you have to draw the diagram. So this indicates the small end, okay, of the connecting rod. This indicates the big end of the connecting rod. This is nothing but the location for G is nothing but the location for center of gravity point. So what's about this L1? L1 is nothing but the distance between small end center from the center of gravity point. So what's about this H? H is nothing but the distance between the top of the this one small end, okay, where the mass is mounted, or this is nothing but the bearing end. Okay, the top of that bearing end up to center of gravity point. Okay, so this distance is nothing but the h distance. So in the problem, the value for the h with us 650 mm. Okay, so get the value for this L1. So only difference between this and h is nothing but h actually from this top, top of that whatever the mass location given at the small end. Okay, so here this distance is given 25 mm. So this L is nothing but, or L1 is nothing but, so this distance, this one distance from center of gravity point up to top of this one, we know 650 mm is given. So this distance is given 25 mm. So what's about this L1? L1 is nothing but h minus this 25. Okay, so in this way you can get the value for L1 as 650 minus 25 means 625 mm. Mass of the connecting rod is also given 37.5 kilogram. And next one important part is given, when permitted to oscillate, the time period is found to be 1.87 seconds. Okay, so time period is given TP equals to 1.87 seconds. Now to get the information about the radius of gyration, okay, that is kg, we know that for a compound pendulum the time period of oscillation, okay, is nothing but TP equals to square root of this one, TP equals to 2 pi into square root of kg square plus h square divided by g into h. Okay, so time period is given here 1.87 second. Okay, so our ultimate aim is to find out the value for this kg. Okay, so h already given in the problem, so 0.65 in terms of meter divided by this g is nothing but 9.81 multiplied by this h with us 0.65, varying both the side. Okay, try to simplify or try to get the value for this one kg. So what's about the kg? Kg equals to 0.377 meter. Now information with us regarding the location of the first mass. The first mass is located at the small end center. Okay, means you have to find out the location for the second mass. Okay, for dynamically equivalent system, we know this relation L1 into L2 equals to kg square. Okay, so from this one get the value for this L2. So L2 is nothing but kg square. This L1 goes in denominator. Okay, so substitute the value for kg square. Kg square is nothing but, if you okay, do the square for this one, so we can get this one as 0.1425 divided by L1 with us 0.625. so after simplification we can get L2 equals to 0.228 meter. Location of the, or information regarding the location of the first mass is given, that mass M1 placed at small end center. Okay, and the second one M2 mass placed at a distance L2 from the center of gravity point, that is from point B. Okay, so let us consider this is nothing but the location B. Here is the location A with us. Okay, this distance is nothing but L1, this distance L2. Okay, so already the distance L2 we get here from this relation. Okay, so next target is to get the value for dynamical equivalent system. So let me here one information regarding this dynamical equivalent system. Okay, so only calculations of this mass M1 and M2 means we can get the information regarding this dynamically equivalent system. Okay, for that this formula already with us, a simple formula, simple relation with us. Okay, M1 equals to L2M divided by L1 plus L2. So what's about this L2? L2 is nothing but 0.228 multiplied by mass of the connecting rod with us 37.5. So what's about the L1? 0.625 plus what's about the L2? 0.228. So after calculation we found the value for this M1 as 10 kilogram. Similarly, get the value for this M2. M2 equals to L1M divided by L1 plus L2. Okay, so put the value for L1 as 0.625 multiply by mass with us 37.5 divided by 0.625 plus 0.228. Okay, so we can get the value for this m2 as 27.5 kilogram. So what's about the difference between the previous problem and this problem? So in this problem the time period is given. So whenever the value for that time period is given, try to use this formula or use this formula relation between the time period and these things. Okay, so already we have seen the formula regarding this one compound pendulum, okay, earlier during the engineering mechanics subject. Okay, just don't go in depth of that subject right now. Okay, just focus or just try to recall this formula. Okay, remember this formula and just write this relation, okay, like this one. Okay, and try to solve this relation for just only to get the value for this one kg. Okay, so further part is very easy. Once you get the value for kg, this relation already has seen during the discussion of derivation, or once again just see here. So during derivation already has seen this one. Okay, m1 plus m2 equals to m first condition, this one m1 l1 equals to m2 l2 second condition. Okay, this is the third condition with us. Okay, from this relation if you just see the last one, l1 l2 equals to kg square. Okay, now see the next important problem. The following data relate to the connecting rod of a reciprocating engine. So the mass is given here 50 kilogram. Distance between the bearing centers with us 900 mm. Diameter of big end bearing 100 mm with us. Then diameter of small end bearing 180 mm. Okay. Time of oscillation when suspended 1.7 second from the big end. And time of oscillation when suspended from small end 1.85 second with us. Determine the radius of gyration of the rod about an axis passing the center of mass perpendicular to the plane of oscillation. Okay. Second point, the moment of inertia of the rod about the same axis. Third point, the dynamically equivalent system of the connecting rod constituted of the two masses, one at the small end bearing center. Okay, so first of all write down the given data. Here the information about the mass is given. So mass of the connecting rod with us 50 kilogram. The next one, center to center distance between the both the ends with us 900 mm. Okay, just convert this into meter, 0.9 meter with us. Then next one, the information given about, see the distance between the bearing center already written by us. Okay, next one, diameter of the big bearing, okay, is given 100 mm. For the small end bearing 80 mm. Okay, given means in case of small, okay, end, we're just using here notation, okay, by giving the suffix as 1. So diameter d1 with us 80 mm. Okay, then diameter for the big end, okay, is with us 100 mm. Okay, so this this also convert into meter. Okay, 0.1 meter we can get it. Okay, next one, next important one relation is given here. Time of oscillation when suspended equals to 1.7 second from the big end is given, and from the small end with us 1.85 second. So as per our previous discussion, just consider the time period TP1 for the smaller end and TP2 for the bigger end. Okay, so TP1 with us 1.85 second and TP2 with us 1.7 second. So our ultimate aim is to find out the value for this one kg. Okay, radius of gyration. Next one, mass moment of inertia, and next one, dynamical equivalent system, that is m1 and m2. So as per information given, first of all draw this diagram. Okay, so here this indicate the small end of that connecting rod. Okay, this indicate the big end of the connecting rod. So what's about this one? This is nothing but the small bearing, okay, location. Okay, so diameter for this one is given 80 mm. Similarly, if you just see the diameter for the big bearing, okay, the bearing located at the big end with us 100 mm, okay, diameter is given. For that we assumed as D2, here we assumed as D1. So distance between the top of the small bearing, okay, up to a center of gravity point is nothing but H1, and distance between the center of gravity point and the center of the small end is nothing but the L1. So this one L1, okay. So next one, this distance indicate from the center of gravity point up to top of the big bearing, okay, big end where the big bearing is located, okay. This distance is nothing but the H2, and this one is nothing but the L2, okay. So as per our earlier discussion, okay, so radius of gyration of the rod about an axis passing through the center of gravity point, this is our first point, okay. So we have to do calculations for this kg first of all, okay. For that, the information regarding this one connecting rod is given. So time period is given, okay. So time period of the oscillation for the compound pendulum when suspended from the small end, okay, is given by this relation with us T1, or okay, just consider this one as T1 equals to, or we can just consider notation as TP1, no problem, okay. So T1, when actually that connecting rod is suspended from the small end, okay. So this is the relation with us 2 pi into square root of kg square plus h1 square divided by g into h1. So this information T1 already with us 1.85, okay, given. So already I discussed about this h1 is nothing but the distance of center of gravity from the top of the small end center, okay, in this way. Then next one is nothing but, so the value for T1 with us substitute here, then value for the G with us squaring both the side, so we can get the relation between this one kg and h1 like this one. So if I do the square from both the side, 1.85, okay, divided by 2 pi will come here, okay, the square of this one, okay, square root automatically get vanish, means we can get here kg square equals to 0.850 h1 minus h1 square. So give the equation number 1, okay. Similarly, the second relation is given, the time period of the oscillation for the compound pendulum when suspended from the big end is given, okay. That relation with us T2 equals to 2 pi square root of kg square plus h2 square divided by g into h2. What's about this one? H2 is nothing but the distance of center of gravity from the top of the big center. So already we have seen that distance top of the big center, okay, big end is okay here on top of that bearing at the big center is mounted here, okay, from this one up to center of gravity point. This distance is nothing but the H2, okay. Now this time period with us 1.7, okay, is given in the problem. So just substitute the value for this one. T2 as 1.7 multiplied by this one 2 pi square root of kg square plus h2 square divided by this one g with us 9.81 multiplied by h2, okay. So similarly, okay, so already we have done this step, okay, earlier. In a similar way, squaring both the side, okay, do the square for both the side, okay, and get the relation once again between the height h2, okay, and this one kg. In previous case we found the relation between this kg and h1. In the next case we found the relation between this one kg, here just look to us here, kg and h2, okay. If you look towards the both the relations a and b, okay, what is the common thing here? kg towards the left side is common, okay, means can easily equate the right sides, okay. So equate right side of this equation number 1 with us 0.850 h1 minus h1 square, and towards the right side of relation b 0.718 h2 minus h2 square, this relation with us, okay. So equate both the relations. So what we get here? So before moving towards next point, okay, just give the equation number C for this one. Okay, so from figure, what we write here? H1 plus H2. From figure, what we get here? First of all, just see this relation written here. H1 plus H2 is nothing but D1 by 2 plus center distance L1, sorry, L plus D2 by 2, okay, written here. Now look towards the diagram. So what's about this H1 and H2? H1 plus H2 is nothing but, what's about this distance? This distance indicate the L. What's about this one? This distance is nothing but the L distance, center to center distance between both the ends. Okay, so this distance is nothing but the L. Okay, so what's about this one? This is nothing but the, so what's about this one? A diameter of this one is given D1. So what's about this distance? Diameter by 2 means D1 by 2. So from this end, I can write this one, a diameter for this one is given D2. Okay, so D2 by 2 is nothing but this one, this distance. So this distance plus center distance plus this distance. Okay, so you can get up to here. What we get from this distance up to here? Okay, this is nothing but the, what's about this distance? Half of this diameter. Okay, means D2 by 2, this distance with us L. So what's about this one? This is nothing but the D1. I'll write here come clearly so that you can get it. This is nothing but the D1. Okay, so what's about this one? This indicate the D2. Okay, so this distance is nothing but the D1 by 2. So same step actually written here. H1 plus H2 equals to D1 by 2 plus L plus L2 by 2. So from this relation, what we get? We can get H1 plus H2. We know the D1 0.08 meter with us divided by 2 plus center distance with us 0.9. Okay, plus this L, this one D2 with us 0.1. Okay, divided by 2. So from this we can write in this way, H2 equals to 0.99 minus H1. Okay, or we can get H1 plus H2 equals to 0.99. Okay, so we can get the value of this H2 in terms of H1. So give the equation number next for this one. So previous relation with us. Okay, equation number. So equation C is here 0.850 H1 minus H1 square, okay, equals to 0.718 H2 minus H2 square. So if you look towards this equation with us in terms of H1 and H2. So already from equation number D, what do we get? We can get the value of H2. Just substitute the value of H2 here and get this relation only in terms of H1. Now towards the left side, 0.850 H1 minus this H1 square. This term will remain as it is. Towards the right side, you have to replace the H2 term by this one, 0.99 minus H1. Okay, in place of H2, you have to write this term. Okay, and here again in terms of H2, you have to write this term. Now just simplify this one. Okay, so this term should be multiply by with the inside terms. Okay, and to simplify, okay, so to the square of this term, okay, multiply by this term to inside terms. Okay, just try to simplify. Here the minus H1 square minus H1 square get cancelled. You look to us, okay, in the next step, so we found the value of H1 after solving this one. So from equation number 1 or equation number A with us, in terms of kg and in terms of H1. So once we substitute the value for this one H1 here, what we found here, we can get the value for kg. So substitute the value of this one h1 here. Okay, so h1 once again here. So what do we get here? After simplifying, we can get the radius of gyration, that is kg. Kg equals to 0.357 meter. Okay, the next target is to get the value for mass moment of inertia. Okay, that can be found by using this one, this relation, I equals to m kg square. The mass value with us 50. Okay, multiply by kg value already calculated by us. Okay, just substitute here and get the value for mass moment of inertia, that is I equals to 6.372 kilogram meter square. The next target is to get the information regarding this one, dynamically equivalent system for the connecting rod. For that, let us assume this one m1 and m2 mass. What's about this one? M1 mass placed at the small end center, and second one m2 mass placed at a distance L2 from center of gravity. Okay, point respectively. So what's about the L1? So we can get a clear idea about this one once we just see that diagram. Okay, so here is the length L1. Okay, and here is the length L2. Okay, so already this one L1 length with us somewhere here, the value for the L1. So from this diagram, what's about this L1? L1 is nothing but this distance with us, h1 distance already given in the problem. So h1 minus half of this bearing diameter. Okay, so what's about the diameter with us? D1. D1, in short, h1 minus d1 by 2. Okay, we can get the value for L1. Already value for this one, h1 with us, d1 with us, substitute here. Okay, so 0.6553 minus 0.08 by 2. So the L1 we get here 0.6153. So once L1 found, next task becomes very easy for us to get the value for next one, L2, by using this relation. For the dynamically equivalent system, so already we know kg square is nothing but L1 into L2. So value for the L1 with us, value for the kg with us. So from this relation get the value for L2. So L2 we can get 0.2071 meter. Okay, here we know for dynamical equivalent system, the M1 relation with us, M1 equals to L2M divided by L1 plus L2. Substitute the value for L2 as 0.2071, multiply by mass value with us 50 kilogram. So again L1 with us 0.6153 plus L2 with us 0.2071. Just do the calculation and get the value for M1 equals to 12.59 kilogram. Similarly, get the value for M2. We know the value for L1 as 0.6153. We know the value for the mass with us 50 kilogram. Then the value for L1 with us 0.6153. Okay, plus L2 with us 0.2071. Okay, simplify this one and get the value for M2. M2 with us. So after calculation, the M2 we can get 37.4088 kilogram. So once again see this problem. Okay, highlights for this problem. In this case, the time period of the oscillation is given by considering the small end as well as by considering the this one big end. Okay, so what are the information given? According to that, just assume that this is the equivalent compound pendulum. Write the formula here. Okay, similarly write the second formula. Okay, here T2 formula. So radius of gyration, this case, in both the cases the radius of gyration will remain same. Okay, and get try to equate both the relations and get the value for this one, or by equating get this relation in terms of the height. Okay, then in the next step try to get the relation of the height only in the single height. Okay, in this way. Okay, just try to solve that relation for h1. So once we solve that, okay, get the value for kg, means our first task is over. Once we get the value for kg, next one get the value for the mass moment of inertia. And next one is very easy. Okay, so dynamical equivalent system, for that get the information regarding this one, m1, m1, m1 and m2. For that, L2 can be solved by using this relation, kg square equals to L1 L2. Okay, so in this way try to remember the steps related to this problem. So next problem is related with the correction couple. Okay, now see here, a connecting rod of an IC engine has a mass of 2 kg and the distance between the center of gudgeon pin and center of crank pin is 250 mm. The center of gravity falls at a point 100 mm from the gudgeon pin along the line of centers. The radius of gyration about an axis through the center of gravity perpendicular to the plane of rotation is 110 mm. Find the equivalent dynamical system if only one of the masses is located at the gudgeon pin, if the connecting rod is replaced by two masses, one at the gudgeon pin and the other at the crank pin, and the angular acceleration of the above rod is 23,000 radian per second square clockwise. Determine the correction couple applied to the system to reduce it to a dynamically equivalent system. So first of all, write the given data like this. The mass of the connecting rod is given 2 kg. Then center to center distance with us 250 mm. Okay, convert it into meter. You can get like this one, 0.25 meter. Then L1. Okay, L1 is nothing but the distance between the center of small end. Okay, up to a center of gravity point. Okay, this distance is given 100 mm. Okay, just convert this into meter, 0.1 meter, we can get it. Then the value for the kg is given 110 mm. Okay, this information with us. Then angular acceleration is given alpha. The next one, our target is to find out the dynamical equivalent system as well as correction couple. So we know the relation, this one, for dynamical equivalent system we know this relation, L1 into L2 equals to kg square. So what's about this one, L2? In this case the value for kg is given, value of L1 is given. So get the value for L2. Okay, so kg with us 0.11 and value for the L1 with us as 0.1. So get the value for L2 as 0.121 meter. So let us consider the M1 is nothing but the mass located at the gudgeon pin or at the small end, okay, side. So what's about this M2 is nothing but the mass placed at a distance L2 from the center of gravity point. So as usual we know the this one formula, M1 equals to L2 M divided by L1 plus L2. So L2 with us 0.121 multiplied by the value for the mass with us 2 kg, just substitute here. L1 with us 0.1 plus 0.121 about this one L2. Okay, just simplify this one, get the value for M1 as 1.1 kg. Similarly get the value for M2. So M2 with us L1M divided by L1 plus L2 equals to 0.1 multiplied by this one mass with us 2 kg. So L1 with us 0.1 plus L2 with us 0.121. So we can get the value for this M2 is nothing but 0.9 kg. So in this way we can get the dynamical equivalent system regarding the mass. Okay, then our next target is to get the value for the correction couple. So we know the relation for that correction couple already as seen during the theory part. So regarding the correction couple, already seen the difference between the torques required to accelerate the two mass system and the torque required to accelerate the rigid body, that is T dash equals to T1 minus T. So this relation, the final relation with us M into bracket k1 square minus kg square into alpha. Okay, now move towards our problem. So already L1 is given in the problem. L1 equals to 0.1 meter. So L3 we can found from this relation. So this indicate the location for mass A, this one, B with us. Okay, so center of gravity point is here, then D is nothing but here, location for the another mass with us here. So L3, how I can get the value for the L3? L3 is nothing but total distance with us, this one, distance between the two masses with us, how much? This one, L with us. Okay, so what's about this one? This is nothing but the distance of the first mass with respect to center of gravity point. Okay, so this one L1 with us. So this L3 is nothing but total distance L with us, L minus this one L1. So L with us 0.25 minus 0.1. So L3 we can get as 0.15 meter. So what's about this K1? K1 is nothing but the new radius of gyration. So what's about the relation? So already the previous case we have seen this kg is nothing but kg square equals to L1 L2. So for the new radius of gyration, that is k1, so relation can get as k1 square equals to L1 into L3. Okay, by considering the correction couple, so we found this one as new radius of gyration. Okay, so get the value for the k1. So k1 square we found like this one. So in previous case already the value for the kg with us. Okay, so correction couple, this relation with us, t dash equals to m into k1 square minus kg square. So k1 square already this term with us 0.015 minus kg term with us 0.11. Okay, do the square for the same. Simplify this one and get the value for t dash. Here t dash is nothing but the correction couple. So t dash equals to 133.4 Newton meter. Okay, this is nothing but the answer for our required question. I hope that in today's lecture problems related with the dynamical equivalent system clear to you. Thank you.